Welcome to the place where we gain knowledge through the lens of creativity. I am Aaron Dworkin, and this is Artful Science. Thanks again for joining me here on Artful Science. Today's show is longevity or cryonics, DNA upgrades or freeze yourself for the future. And our guest is Natasha Vita-More, who serves as Executive Director of Humanity Plus, is an innovator of the future body prototype, has achieved key scientific breakthroughs, Harvard and Stanford Lecturer, and former professor at the University of Advancing Technology. Natasha, welcome to the show.
Thank you. It's a delight to be here.
Oh, it's just wonderful to be able to have you here. And so I figured that, first, you're completely have a fascinating background. And I was wondering if you could how would you describe yourself, like in terms of your approach to these issues, which cover a variety of different things that impact humans? How would you describe your work?
I would describe my work as an exploratory adventure into the sciences and technologies that will possibly, if not probably, help to change our future so that we can become a more humane humanity.
Wow, awesome. So one of these things, of course, that you study and research is not just our humanity, but really life extension, right? How can we somehow extend our longevity? And one of those ways is through cryopreservation, or what some people just call cryonics. So could you kind of just share with us and for the audience, because a lot of people are like, okay, so what are we talking about? Could you just help us decide what is cryonics?
Cryopreservation is a valuable technique for the storage of biological materials. We know that from infertility, that field, and freezing or vitrifying embryos, cells, um, also sperms and eggs. So it came about and became well known through infertility. Today, we're vitrifying organs for organ transplants. Cryopreservation is the vitrification of cellular structures, and in cryonics for human longevity as Plan B, cryonics is a preservation of the whole body or just the brain for possible later reanimation or reviving based on the strategic analyses of where the future is heading as far as biomedical technologies and advances in nanomedicine. So it's not quite freezing, but that's an easy way to say it. It's taking the human body after death, after pronounced dead, and quickly through a team of high-level medical surgeons and doctors and emergency team to put that patient on ice, to lower the temperatures, and to put in a system that will preserve that body in vitrification.
Gotcha. So, it seems very intense process, obviously, but this is, and so our audience can understand this is something that's actually taking place now, right? There are people
Oh,
that
yes.
have been for a while. I hear rumors of, like Walt Disney or, going back that far, but people are actually going into cryopreservation today. So could you kind of just share, A, is that right? And, or let me just start there. Is that right that it's actually occurring today?
Yes, indeed, you're absolutely correct. And that there are many patients who are currently in doers at Alcor Life Extension Foundation, as well as other chronics facilities around the world. And those patients have opted not to have the finality of death, but to look at the advances in medical technologies. And let's say that chronics is where today's medicine leaves off, chronics picks up and offers a possibility for curing the disease that caused the death in the first place and bringing that person back to life. So one could see it as being in a type of coma or a state of stasis, of non-existence, but still being preserved, held in that in-between state. And I think that frightens a lot of people, but for most of us, it's It's better than the alternative, which is the finality of death.
Yeah, absolutely. Right. There is definitely a lot of people who want to ideally avoid that or are facing a particular terminal illness that at this point we may not have solutions for. So, is there any sense that people have today of when people could be revived, or is that just kind of an open book? At this point, it's just about let's just preserve, let's just put on hold, and then we just don't know? Or is there any
Mm.
projections or data as to when they think they might be able to begin to bring people out of cryopreservation?
Yeah, it's a very good question. It's, in when we are ill, we will do anything to stay alive. And then we have to deal with the FDA and certain regulatory systems that will either afford possibilities to mitigate the disease that's causing our illness or not. And chronics is approved to be an alternative process. So it's a legal process. It's highly regarded and respected process. And again, because the field of infertility has proven that it is a reliable process for simple cells. Now, when it gets to complex animals, such as the human being, we are extremely multifaceted, complex system that is constantly ushered under the central nervous system of feedback and control. Preserving or cryosuspending a human being is a very complex matter. So when the idea of it working is supposition, to be sure, but it looks more possible than not possible. So I will say this to answer your question directly. Has been an animal that has been put into vitrification, into chronics, and brought back. In fact, there's a number of different types of animals. The most obvious and well-known simple animal is the C. elegans, which is a tiny microscopic nematode. And in fact, my work in chronics research is with this simple animal, the nematode, where I trained it to perform a task, vitrified it, put it into the chronic suspension, brought it back to, revived it into the existence of life, and tested its learning capabilities and proved through my scientific research that long-term memory was functioning after being brought back from the state of suspension or cryonics. So, but that's a simple animal. I mean, it has 302 neurons in its extended brain. So a human is very complex. So we would need extreme advances in biomedical technologies such as nanomedicine to bring that about. So what is a trajectory for prediction in that regard? Well, it seems plausible that'll probably happen within the next 50 years to 100 years. And I don't think that is a conservative view or maybe a highly progressive view. I think it's a very based on a mean. Um, on, I think we would say that if we look at how genetic engineering is advancing and look at nanomedicine was something that was a fairy tale 20 years ago, but it's starting to take root. And looking at gene therapies and looking at the advances in our understanding the makeup of the human body, it seems plausible that we will try to revive um, people in 50 years.
Right. Awesome. So, I mean, it sounds obviously incredibly complex, especially from an artist's perspective. And so, one thing that I've heard about with the cryopreservation, that one of the issues that relates to this process, as you described of vitrification, is damage to cells that with water or in our bodies freezing, and that causes damage. Is that something that the current science is kind of saying, well, we don't have this solved, or this is something that would be one of those components solved in the future? Or where is the kind of data, or what is our understanding of that at this point?
Okay, to answer your question directly, I'm going to give you two examples. The first example is when a patient is put into cryonics. That procedure of vitrification is assisted with a cryoprotectant. And that cryoprotectant is sent through the body to protect the cells from the damage of freezing, which would be cracking. We know when ice cracks. And so that cryoprotectant is a highly sophisticated um, mitigator of that type of damage due freezing. So yes, it's a big concern, and the cryoprotectants keep on getting better and better as new advances are coming about and they're being approved by the FDA. Another issue there is that reviving a person who's in chronics is not a simple task, as you duly noted. Um, However, when we're thinking about that, it's the amount of effort that will need to go into that is so extreme that we can't compare it to any current medical practices other than maybe dealing with a tumor in the brain or extreme repair of cellular damage due to cancers or other types of diseases. And if we look at it in a scale of history, 200 years ago we would never have thought of opening up the brain and putting a chip in the brain, or reviving some of the neurological damage through dementia, or replacing a heart, or kidneys and other organs, and reversing the damages of cancer. Cancer, for example, was a death sentence 50, 100 years ago. And it was almost, people were shamed if they had cancer. They weren't positive people, they were negative. So, but this whole shift in how we accept disease and understand disease, and that it's not an obscure anathema, is something that is very clearly unraveling and understood the more we understand what's in our DNA and what's in our proteins, and all the composition of matter, of molecular systems, and how they function together. And it's no longer something that we can't see. We can see what goes on in the function of the cells in their processes. And there's a lot to be learned. And certainly for chronics to actually be successful, there's going to be leaps and bounds in medical interventions and more seamlessly understanding the functions of cells and the whole system. But I think we're coming close to that, and just through our curiosity that we're driven with, our sense of creativity and problem solving. And death has always been a problem. And it's a problem that people over the eons have tried to resolve. And of course, you can look at it through other philosophical, theoretical approaches and religious approaches, which, and some psychological approaches that think it's natural to die, and it's part of our process, part of that life cycle. But that's not written in stone. And who is to say that the process of life needs to be terminated at 70, 80, 90, or 100, and a maximum lifespan of 123? Perhaps we could live to 200 or 300 and be productive, healthy beings.
Wow. Well, this is truly fascinating. And unfortunately, we're just about out of time. But I always like to ask of all of my guests, since we're here at the intersection of the arts and sciences, do you have either an arts specific just practice that you do and or arts discipline that you love to appreciate?
I love dance. I love filmmaking. I love design. My whole world is based on the visual interface. And yes, I do have an undergraduate degree in art, and my doctorate is from the Media Arts, Architecture, and Design department of the University of Plymouth. So art and the arts from a larger uh, interface of the humanities is very important in my work. And I think that the artfulness of life is quite beautiful. And I think that your program is an example of taking art and giving it that science of meaning and exploration and curiosity that makes us who we are.
Well, thank you so much, Natasha Vita-More, for helping us gain knowledge through the lens of creativity here on Artful Science. Thanks so much for joining us.
Thank you.